All right, so it's the final video for week 4, and we're going to talk about sensory receptors. We've got three main objectives here. The first, maybe just one of these is review, so that second one. I don't talk about motor neurons or the different types in 220, so this will likely be new, at least to a bunch of you. And then we're going to talk about a few other types of muscle receptors. So when it comes to types of motor neurons, there's actually 3 types. So we've got alpha motor neurons, which are big, they're large, they innervate what we call extrafusal muscle fibers. In other words, when you think of a muscle, like that's what you're thinking of, the extrafusal fibers, the ones that produce force. Okay, and so these are the ones that cause muscle contraction or signal the muscle time to contract. Then we've got beta motor neurons that innervate both extrafusal and intrafusal fibers, but they're a sensory neuron. Okay, and what we mean by extrafusal, that's kind of the muscle fibers that you think of. And then we've got these intrafusal, or these fibers that get tied into, or they're sensory, okay? And so that's where muscle spindles, for those of you that have heard of those are a type of intrafusal fibers. They're deep inside the muscle. And then we've got gamma motor neurons that only innervate intrafusal fibers, okay? And so those are the 3 main types. So oftentimes we'll talk about alpha and we'll talk about gamma. I don't talk about beta very often. So with the types of receptors, there are 5 main types. So we've got photo, chemo, mechano, thermo, and nocii. Okay, and they all sense different things. So photoreceptors are activated by light, chemoreceptors are activated by chemicals, mechanoreceptors are affected by or stimulated by changes like in their shape actually. So when the mechanoreceptor becomes deformed or changes shape due to a physical change or vibrations, then they're activated. You've got thermoreceptors in your skin, and then you've got these things called nociceptors that detect pain, and then they're everywhere. And I throw this out every time I talk about them, is that there is actually a little bit of debate as to whether specific pain receptors exist, or if you're just, when you feel pain, you're just overexciting these photo, chemo, mechano, or thermal receptors. I'm not sure which way I go, believe here, but I think there probably are pain receptors, but that's another story for another day that we're not going to get into. Now, within the muscle, there are different kind of receptors. You could argue that they're a type of mechanoreceptor. And so we've got muscle spindles, Golgi tendon organs, Pacinian corpuscles, and Raffini endings. Okay, and so I'm going to talk a little bit about each of these, and I know that you'll get to them in lab as well. So muscle spindles, this is actually a spindle here, but spindles detect length and the rate of change in length. And so how fast is a muscle lengthening, and that's what it's looking for. And really the rate of change is what it is most activated by. Okay, when a muscle spindle is activated, we decrease the stretch or the contraction, not the contraction, we decrease the muscle stretch. So for example, the patellar tendon knee reflex, you get hit on the knee, that stretches your muscle out, and what happens? Okay, and by muscle, it's stretching out your quads, okay, lengthening your quads, and not that much, but it's just doing it quickly, and so your spindle activates, ultimately causes quadricep contraction, okay? Now, when the spindle is stretched, it sends signals via afferents, causing the muscle contraction. Now, we have gamma neurons inside by these muscle spindles that help keep the spindle taut, okay, kind of in its place. Now, during normal contraction, we don't want to activate these gamma neurons. We don't activate the spindles because that would cause or prevent lengthening of a muscle. And like if you want to walk, you have to lengthen your muscles. And so what happens is these gamma neurons will inhibit the spindle. We call this autogenic inhibition. Okay, and so these are stimulated. These require a big stimulus, but they have a big response. Okay, and so then we've got a Golgi tendon organ, or GTO, and that's what this car is. It's GTO, but your GTOs and your muscles look nothing like a car. And these sense tension and rate of change in tension. Okay, when your GTO gets stretched out, it causes muscle relaxation. And this is done to prevent injury. Okay. Now, in an untrained individual, these are activated almost immediately. But in a trained person, the more trained they are, the more inhibited, I guess, they are, which can also lead to injury. Okay. So, for example, let's just say that someone says, "Hey, hold this box for me," and it's really heavy. And so they give the box to you and they let go of the box, and it's so heavy you can't hold it. What happens at times is that you immediately just drop it. Okay, and what's happening here is you're stretching out your muscles to try and resist that force, but there's so much stretch that your GTOs go, "Yeah, it's not worth it. We're going to relax the muscle," and then you drop that. Okay. We've got Pacinian corpuscles, and so these are in the skin that respond to changes in pressure. They sense high-frequency vibrations and pressure change, but it doesn't take a big stimulus. Okay, and so these cause small amounts of change, and so they're very fast adapting and they respond to the stimulus quickly. And so when you go for a long car ride, how do you feel when you get out of the car? Okay, and the answer is you're stiff. And the thing is, all you've been doing is sitting there. Okay, imagine a day where you've sat in class all day. Are you stiff like you are when you get out of a car? And the answer is no. And the reason being is that a car, it's not a smooth ride. Even if you're in the best car in the world, it's not a smooth ride. There's some bumps and all that. And so your muscles tense up to try and maintain posture, that sort of thing. And this is due to Pacinian corpuscles. Okay, and then the last one is Raffini endings. And so these are low frequency, or they sense low frequency vibrations, and they sense whether or not your skin's being stretched out. These cause small changes as well. They're very slow to adapt. They help, they're very important when it comes to like kind of fine motor control, grip, finger position, stuff like that. And what they do is they inactivate muscles, okay? And so with deep tissue massage, this is what we're trying to activate, those Raffini endings, so we cause the muscle to relax. That's how we're going to end week 4.